If we had put this in Öland, in the south or east of Sweden, where it's quite dry and it's not so good for grassland, but it's good for maize, I think the differences would have been bigger in the land area to produce 1 kilo of milk. If we look at the greenhouse gas emissions for this whole system here, not including anything from land use and land use change, they are very, very similar. It's around 1.1 kilo CO2 equivalents per kilo of milk. And when we model this and try to understand how different ways of choosing this feed, growing more maize or less maize or more grass or very much more grass, trying to understand what will happen with soil carbon changes. There is one very obvious thing here, and it's when we test this, how much carbon do you have in the soil from the beginning? That seemed to be one of the most vital things to understand here. And we used soil sampling from this area of Sweden, and now we are certainly not talking of degraded soils. These are very, very good soils. And in the Swedish soil sampling, the cattle farms in this area, they have a soil carbon of around 2.5 in average. There have been cattle for a long time, and we don't get so much raising up of soil carbon because I think they are very close to some sort of equilibrium. So this is not degraded soil. So we can track some soil carbon changes, but when we put them into the, compare them with this total greenhouse gas emissions from milk, it's not that they can compensate a lot actually, maximum 10%, even that. And my belief is here that we already had a quite good soil carbon status here. When we have these feed rations where we put in maize instead of grass, they seem to lose soil carbon. And I think this is an interesting thing. And now we see in Sweden and Denmark that maize is increasing on the benefit of grassland. However, feed rations with maize, they also tend to have a lower total land requirement. So if you are going to do some whole system analysis, how is this surplus land use? If you get maybe 10, 15